Our goal today is to have a look at what the function of y equals cosine of x or y equals sine of x looks like. Now, one thing I want to point out, so far I've been trying to drill into your heads that cosine is associated with x and sine is associated with y. And that is definitely true if we're looking at the points on a unit circle. The x value is the cosine, the y value is the sine. That's not what we're talking about today. We want to look at the graph of y equals sine of x or y equals cosine of x. So in this situation, what I want to say is that x value that we're plugging in is going to be some kind of angle measurement, right? And the y value will be, in this case, the sine of the angle measurement. Or, in this case, x will be an angle measurement, and the y value will be the cosine of that angle measurement. So to get a picture of a graph, it can be confusing. Think back to your days as a middle school student. You were learning about a graph like y equals x squared. And we wanted to get a graph of that. What you would do is you would make a table, and you would pick different x values. Maybe x is -2, x is -1, 0, 1, and 2. You'd plug them into the function for x, and whatever y value came out would go on the other side of your table. And then you'd have a bunch of tables like with a -2 and a 4, a -1 and a 1, a 0, 0, 1, 1, 2, 4, whatever it would be. You would plot those points, connect the dots, and have a graph. That's what we want to do with the sine and the cosine functions, to see how they graph when the x value is now an input, an angle, and the y value is the sine or cosine of that value. Now, one of the things that's not so pleasant is I can easily ask you to square a number. So if I want you to find the graph of y equals x squared, no problem. But if I want you to find like the cosine of something, like without a calculator, there's no way to do that, and we can't really think of those numbers. So we're going to go back to our wonderful trig unit circle thing to help us find the cosine and the sine of different angle measurements. So here I've created a table, and this table goes up by multiples of pi over 6. I've got 0, pi over 6. This is really, if you think about it, this is 2 pi over 6. This is 3 pi over 6. This is 4 pi over 6, 5 pi over 6. And I've set up a slider that also goes up in multiples of pi over 6. Now, unfortunately, I can't get decimals to show this as, if it's pi over 6 or 2 pi over 3 or what have you, but that's what it's doing. And we're going to start to fill in this table. So if I was going to try to figure out, for example, I'll go into the details with that later on, but what you're going to do is use this table to graph the function, use this slider to create various reference triangles, and whether you're finding the graph of y equals sine of x or y equals cosine of x, you'll look at different parts of that triangle. When you guys look at the sheet that I'm sharing with you, I've got this slider on there. I'm going to show you right now. Here's the slider, and I've marked those little, I've marked these little white dots with what they actually are. So I've marked them as pi over 6, pi over 3, pi over 2, 2 pi over 3. So as you're going through to make your different angles that go into the trig functions, you can use that as a reference to tell you where you are on the table in case you get lost, So that's the goal. We'll use what we know about SOHCAHTOA to evaluate the sine and the cosine so we can fill in these tables. We'll plop in these y values as we find them, and then decimals will plot the points, and it'll give us a general idea of what each graph looks like. That's the overview. I'm going to explain each step in detail in the next few videos, but that's the goal. What's it look like when we graph y equals cosine of x, y equals sine of x, where the x value is an angle measurement, and the y value is either the sine or the cosine of that angle measurement based on which one we're looking at. Let's do this, man. It's going to be awesome.